sklearnisotoniccheckincreasing check increasing. Description: explain in detail. The check increasing method is a utility function within scikit-learn's isotonic regression module. It's designed to validate whether a given input sequence is monotonically increasing. This is crucial for isotonic regression, as it ensures that the fitted model produces a prediction that adheres to the assumption of a non-decreasing relationship between the input and output variables. Inputs. Input 1. Explain in detail why this input represents the sequence of values that need to be checked. For monotonicity, it can be a NumPy array or a list of numerical values. Input 2. Explain in detail. Increasing this Boolean argument specifies the direction of the expected monotonicity. If true, default, the function checks for a strictly increasing sequence. If false, it checks for a strictly decreasing sequence. Outputs. Output 1. Explain in detail is increasing a Boolean value indicating whether the input sequence is monotonically increasing or decreasing, depending on the increasing argument. If the sequence is strictly increasing or decreasing, it returns true, otherwise, it returns false. Steps. Step 1. Explain in detail. The function iterates through the input sequence y. Step 2. Explain in detail for each consecutive pair of values. It compares them based on the specified direction, increasing or decreasing. If the comparison fails to satisfy the monotonicity condition, e.g., a decreasing value is found in an increasing sequence, the function immediately returns false. Metrics. Metric 1. Explain in detail. There are no specific metrics directly associated with the check increasing method itself, as it's primarily a validation function. However, the success of isotonic regression, which relies on this function, can be evaluated using metrics like mean squared error (MSE), R-squared, and others. Visualization plots. Visualization plot 1. Explain in detail a simple scatter plot of the input values y against their indices can be used to visually inspect the monotonicity of the sequence. Fine-tune parameters. Parameter 1. Explain in detail. The increasing argument can be adjusted to check for either increasing or decreasing monotonicity. Uncertainty methods. Uncertainty method 1. Explain in detail. This method doesn't directly involve uncertainty quantification, as it's solely a validation function. Challenges and fixes. Challenge 1. Explain in detail. The check increasing function assumes that the input sequence y consists of numeric values. If the sequence contains non-numeric elements, such as strings or objects, the function will likely fail. Sample use case that resulted in challenge 1. A user might inadvertently provide a sequence containing mixed data types, including strings. This could lead to an error during the comparison of values. Fixes to challenge 1. Ensure that the input sequence y consists entirely of numeric values before calling the check increasing function. This can be achieved by filtering out non-numeric elements or by converting the sequence to a numerical representation. Challenge 2. Explain in detail if the input sequence contains duplicate values. The check increasing function might not be able to correctly identify whether the sequence is strictly increasing or decreasing, depending on the intended behavior. For instance, if the input is 1, 2, 2, 3, it might return true for both increasing and decreasing sequences. Sample use case that resulted in challenge 2. A user might provide data where certain values are repeated, leading to ambiguity in the monotonicity check. Fixes to challenge 2. In cases where duplicate values are present, consider whether you need to define strict monotonicity where each value must be strictly greater than the preceding one, or allow for non-strict monotonicity where values can be equal. to their predecessors. If strict monotonicity is desired, remove the duplicate values before using check increasing. Otherwise, clarify your expectations about the handling of duplicates.